Good morning, Mr. Chair, members of the Commission. For your consideration today is the culmination of about a year's worth of work working on the Santa Ana Watershed Weather Modification Feasibility Study. This was an effort that the board requested us to investigate. We went through an RFP process and hired North American weather consultants. They've been conducting this study over this past year. We brought to you an interim report indicating that the initial tasks indicated that it did appear to be feasible, but we got your concurrence that it made sense to proceed with the study. At that time, there was also a request by the Commission to have presentations given to some of the member agency boards. That has taken place. There have been presentations about cloud seeding or weather modification for the Western Municipal Watershed Board, as well as the San Bernardino Valley Municipal Watershed Board. In addition, Eastern has requested presentations, and also the City of Rialto has requested presentations. So a lot of interest, a lot of people wanting to get up to speed to understand this approach. In addition, this entire study has been reviewed by a technical advisory work group, basically the staffs of all the member agencies, staffs from the various flood control districts, and various other interested parties who would want to review the document. And we've had numerous meetings with them to get their comments, their feedback, modify the study appropriately. A draft final report was shared with them. Those comments have now been incorporated into the final report, which now has been distributed to all of the staffs of the member agencies. At this time, we do have Garrett Kamens, who's president of North American Weather Consultants. He has a PowerPoint presentation prepared, and he'll walk you through that, basically providing that full background again about the study and what conclusions and recommendations he has. And then staff will conclude with some final slides to indicate our recommendation to you. So with that, I'll go ahead and turn the time over to Garrett Kamens. Garrett, if you want to go ahead and direct our staff to advance slides, we'll do that for you.
Yeah, great. Thank you. It's good to be here again with the Commission today. As Mark mentioned, we met a few months ago, and as we wrapped up this 11-month study, it's great to have the opportunity to provide some conclusory remarks. Go ahead and advance to the next slide. In fact, you can skip one more slide as well. I just wanted to start with a quick recap of what cloud seeding is and how those mechanisms work. What we're looking at doing is taking storms that come into the Santa Ana River watershed and augmenting the rain or snowfall that occurs in those areas through very natural means based on basic chemistry. What happens is we have moist air that comes in, generally off the ocean on the west side of the watershed. And as the storm travels east, we will seed the storm with a combination of materials consisting primarily of silver iodide. And those materials activate the freezing and coalescence process of water droplets inside the cloud system. So what we're doing is we're tipping the equilibrium scale of freezing inside of a storm system and using silver iodide to form snowflakes, hailstones, or raindrops inside the storm. These then fall to the ground as precipitation. Historic scientific study and review have indicated that depending on the circumstance of the seeding, cloud seeding will have anywhere from a 5 to 25% impact on the precipitation that occurs during a storm sequence. Go ahead and advance to the next slide. Now, to provide the seeding agents into the storm system, as we've gone through the study, we've evaluated 3 different seeding processes, 2 of which occur from the ground, 1 occurs from the air. The most basic process is to use a cloud nucleating generator, an object that looks something like this image right here. These burn a solution of silver iodide dissolved in acetone, and that creates a plume or kind of a smoke cloud, though invisible, of silver iodide that will be lofted up into the storm system through the winds and an orographic process, which is the process of air hitting the mountain and then lifting due to the land barrier. We've also looked at a second ground seeding method, This uses not proprietary equipment referred to as AHOGs, or automated high output ground seeding systems. And these AHOGs use seeding flares. These are burn-in-place flares that ignite inside these metal cylinders that you see coming off of this flare rack. And these release a higher concentration over a much shorter period of time of silver iodide. There's no solution that these are burning in. These are used in a couple areas where there's rich moisture, generally in coastal areas, where we look for a rapid release of high concentrations of silver iodide. Go ahead to the next slide. As we've evaluated your watershed over the last 11 months, we've come up with a proposed array or network of seeding systems. These two yellow systems over here on the left, these represent those flare trees that we just looked at. So again, we're looking at coastal moisture. So as the storm comes fresh in off the coast, we're going to target that with high concentrations of silver iodide. And then we've proposed an array of ground seeding or ground nucleating generators located at the base of the 3 inland mountain ranges. And these would provide that continuous plume of silver iodide that would be lifted by the natural wind effects that occur as the air from the storm hits these mountain ranges and is forced upwards. So this is the proposed array of ground seeding, of the ground seeding network. Go ahead to the next slide. We've also evaluated the possibility of seeding from the air. When we seed from the air, we use flares very similar to those. In fact, they're the exact same flares found in those seeding trees. They're just mounted to the wing of a plane. Again, these burn in place, so there's no trajectory or no flight. They never leave the plane, so there's no risk of a forest fire or anything like that. But they burn along the plane wing, and they introduce this silver iodide directly into the storm cloud. So these are released obviously at elevation. This provides some advantages in some weather conditions. There is preference to seeding from the air. In other weather conditions, both ground and air can be effective, and we've been careful to evaluate the potential for both types of seeding. We'll go ahead and move on to the next slide. After this slide, I'm going to pause and see if there's any quick questions. As we've evaluated the effectiveness of seeding both from the ground and from the air, we've used a multitude of data. A lot of this comes from NOAA, from the National Oceanic and Atmospheric Organization. So they've provided storm data from historic storm events, and we use a modeling tool called HighSplit. And this modeling tool is able to recreate storm conditions from a past storm or to predict storm conditions for a future storm and overlay projected dispersion of elements released at particular locations. So we've looked at what the dispersion of silver iodide would look like when released from ground generators at the designated location. Now, we did this for a series of almost 50 storms. And so you'll notice that there's some generators where the plume is being dispersed over the desert, not over primary target areas. These generators would not operate under these storm conditions, but we wanted to evaluate each potential site and each potential location for a number of different storm conditions to ensure that the majority of the plumes would disperse into storms above our primary target areas. And those target areas are outlined here in yellow. And they consist of the higher elevation upper portions of your watershed. Now, there is going to be some downwind effect in areas here in the Central Valley as well, and we'll talk about that in a little bit. So that's the basic fundamentals, the basic mechanisms for which cloud seeding is performed. Are there any questions from the commission before we proceed?
Yeah, I had a really quick question. What are the other colors indicated of? So the dark blue, the green, and the lighter aqua blue color.
That's a great question. These are relative concentrations of the silver iodide at those distances. So this will be a higher concentration, a lower concentration, and then a trailing concentration in those aqua areas. Based off of the wind speed, those concentrations will disperse, more quickly or more rapidly. So this was probably a slower storm where the material hovered for longer periods of time close to the original dispersion location.
Garrett, this is Kelly Rowe.
Hey, Kelly.
Yeah, we've talked over the last year about this because I'm keenly interested in this. I thought I'd point out that this is one of the original simulations, which include 19 stations, and you've dropped it down to like 12 now.
Yeah, I think we're at 15, and 15. I've got a slide that will show that as well. Actually, 2 slides ago we showed the 14 locations, and I did present this with the original design with the intent of showing some of these outlier sites that we eventually abandoned after further study.
Right.
So we do want some redundancy. We do want sites located in areas that will only operate for certain wind regimes, but we don't want too much superfluous equipment on the ground because that increases the cost at a minimal benefit to the water district. So some of these sites have been removed because we found that they rarely benefited those target areas.
Right. Well, I see you have a couple of stations by the Santa Ana Mountains on the southwest and the southeast, the San Jacinto Mountains, but there's just a few there. Why is it so few over in both of those southerly ranges?
That's a great question. So we can start with the southwest area here first. This is a relatively small target area. This target area presents a number of technical challenges. Being directly off the coast, there's not a lot of lead time for the material to disperse and get into the clouds and instigate a positive seeding effect. So we used high output ground seeding generators here, and we used 2 of those. So even though there's only 2 sites, the amount of seeding material that we can release from these sites is tremendous. And it, again, releases over a short period of time. This site was eventually abandoned because we felt that there would be no real benefit in the actual designated primary target area. There could be some downwind benefit, but not dramatically more downwind benefit than we would capture from these 2 other sites. So in terms of efficiency, we elected to remove that 3rd site at the southernmost portion of that southwest target area. And I just forgot, you can't see my mouse because I'm not the one controlling this presentation, so I apologize. But those 3 sites in the southwest, the one that he's hovering over right now, that's the one that we elected to remove for redundancy purposes.
Well, wasn't it also a concern about the fire damaged area and potential debris flow liability or liability associated with infrastructure that's inadequate to handle?
Yes, and that was one of the things that we were balancing as well. As Riverside Flood Control District had some concerns about improper infrastructure in some of this inland portion, and then also in the more southeasterly portions of this target area, some of those areas up above Orange County. So there were some flood concerns as well that went into the weighing of our decision to remove that equipment.
Well, it seems that with this figure, a lot of the benefits of doing cloud seeding is related to Western and Valley and IEUA, a little bit OCWD and Eastern. Just the way it is because the topography.
Yeah, as you'll see in a few slides, we'll show a table of our projected increases across all of these target areas, and you'll definitely see a more substantial increase, particularly in these 2 northern target areas. These are just areas that receive more natural rainfall to begin with. They also represent larger land masses. So these are definitely the primary focus of the program, but there is still additional benefit to be had in these southern portions as well. We just didn't want to overbuild the southern programs to where the expense was greater than the benefit that would be achieved in those target areas. But there is still potential for increase, not just in the primary target, but in some of this inland area in the Lake Elsinore watershed and some of these other watersheds, smaller, more minor watersheds internally. There will be some downwind effects. So we do believe it would be productive to operate in the southwest target, just not to over operate.
Yeah. Well, I think this is a good start. Once we start operating, we can see how we can enhance it, make it better.
Yeah, absolutely. And we do periodic reviews with all of our programs to make sure that they're operating optimally. And that's something you'd want to look for in a contractor as you go through the RFP process, is a history of periodic reform and amelioration on their programs, because that periodic review is critical. Climate changes and other things change. You want to make sure that you're adapting for those.
Yeah, thank you.
Yep. Any other questions before we move on? Okay, we'll go ahead and move on to the increase estimates then. This is the interesting part. Go ahead and advance. You can advance 2 slides. So here's our total projected increases. I have 2 tables. As I mentioned before, we evaluated the impact of aerial and ground-based seeding. So the first table represents ground seeding only. The second table represents the benefits that we believe would be achieved through a mixed ground and aerial program. Now, it's important to note that we limited the aerial component to the northeast target, and we did that for a number of reasons. First being cost and benefit balancing. So the northeast and the northwest target areas were the 2 target areas that had enough potential that they merited the extra or additional expense of operating an aircraft in to serve those target areas. The other were technical limitations with all of the major airplanes and traffic patterns that exist in the LA basin in general. We do not guarantee at this point in time that we would be able to get FAA approval to fly even to benefit the northeast target area. We do know that it would be nigh impossible to fly to benefit the southwest target, and very difficult to get approval to benefit the northwest target. So the northeast target had a good balance of potential for FAA approval as well as potential augmentation benefits. So we limited aerial seeding to that target area. And in fact, in our conclusion, in our actual report, our final recommendation is that SAWPA would consider beginning the program with just ground support, because that's where you're going to get the biggest benefit and the biggest return on your money, and then consider aerial support if additional seeding is needed years down the road. But let's go ahead and look at these increased estimates. So for ground only seeding, you'll see on the bottom row of that top table, that average natural stream flow was measured to be about 105,000 acre feet. That was somewhat limited to the stream gauges that we had access to. So this might be slightly underrepresented, which is good, because that slightly underrepresents, or that means that our total projected increase is underrepresented rather than overcommitting. But we believe that the average stream flow is around 105,000 acre feet. We believe that a well-executed ground-based program could increase that stream flow by about 8,193 acre feet for a roughly 8% overall annual increase in runoff. With aerial support, you'll see at the bottom row of that lower table, we estimate a roughly 12,000 acre foot increase for about an 11% overall increase in runoff. So there is about a 3.5% additional increase or supplemental increase that comes through operating the plane. But as we'll see later, that comes at a much higher expense than the original 8,000 that can be achieved through a ground-based program. Any questions on the increases before we move on?
Nope.
Okay, we can go ahead and move on. You can proceed again 2 slides. We'll skip the top. Okay, one of the things that we need to consider is not just the increase, but when the increase might be too much. So there will be times during the operation of a cloud seeding program where we need to consider suspending the program, either momentarily for a single storm or for an extended period of time. There are a few indicators that we look at for suspension. Temporary suspensions are often based off of National Weather Service flood warnings. So if there's a severe storm, precip, or flood warning, those are all things that are going to instigate conversation or an automatic suspension. In addition to that, we've come up with some custom suspension criteria based off of infrastructure concerns, primarily in the inland portions of your watershed in the Riverside County area. Due to concerns related to the Riverside County, we recommend suspending seeding operations if hourly precip will exceed 0.5 to 0.7 inches, or if a 24-hour precip schedule or forecast is scheduled to produce 2 to 3 inches or greater of rain. These levels correlate to a 1 in 2 to 1 in 5 year storm event. So these are more significant storms. These types of storms are generally self-sufficient So there's a lot of mixing already taking place in the storm system. The process that we're looking at instigating is already happening very efficiently on its own. So these aren't necessarily storms that benefit a great deal from seeding either, but they do pose higher risks for flooding and for damage to infrastructure. So we would recommend suspending on a storm-by-storm basis in the southwest and southeast target if any of these or if either of these two conditions will be met. That shouldn't have a dramatic impact on the effects of the overall program. Go ahead.
Yes, Garrett, I had a question. Based on what Commissioner Rowe brought up with regards to debris, et cetera, flood control also, at least Riverside County, sends out crews, including engineers, to oversee when a rain's coming in where a fire has been. Did they express that as well, that there may be isolated areas?
Yes, and we addressed fires, particularly in your area, and we'll actually touch on that in 2 slides. So we'll look at that in a little bit more focus and more detail.
Okay, you can proceed. Thanks.
Any other questions before we move on? Okay, let's go ahead and move on 1 slide. Now, I mentioned earlier some downwind effects from seeding in the southwest target. Right now, I have pulled up in red. We have the watershed for Lake Elsinore and the San Jacinto watershed. This area will benefit from downwind effects, and we balance this, and we talk to a number of different member agencies and a number of different staff to make sure that we were balancing, again, flood concerns as well as benefit to some of these naturally occurring reservoirs and water bodies. And we believe that the suspension criteria that we set up does a great job of balancing Riverside flood control's concerns while continuing to promote the enhancement and augmentation of rainfall that would benefit Lake Elsinore and some of these other water bodies. Go ahead and move on 1 slide and we'll address the forest fires or wildfires. So wildfires are of particular concern. This is another area in the RFP where we would recommend that as you approach the selection of a contractor to operate in your watershed, that you choose or select a contractor that has experience working and operating in areas where wildfires are common and are frequent. Wildfires can cause a number of issues: debris flow, additional flood risks. They can damage soil. Obviously, we can have various degrees of damage to vegetation. And based off the severity of the wildfire, the location of the wildfire, certain conditions that existed during the wildfire, a wildfire may cause either temporary or long-term suspensions to the program. We operate in Fresno to benefit the Kings watershed. A couple years ago, they had a large wildfire inside their watershed. The wildfire was located at an isolated location. There weren't substantial debris flow concerns. So even though the wildfire was vast and large in terms of overall acreage that was encompassed by the fire, we operated as normal during that season and in subsequent seasons. Now, we communicated more regularly with the water district and with other bodies that were interested in potential flooding. There was increased communication, but there wasn't a dramatic increase or change to the program itself. Now, in other areas like Santa Barbara, we've had significant wildfires that caused moonscaping or the glassing of soil, and there were severe flood risks and debris flow risks in populated areas. And we've had parts of that program that we've suspended for 2 to 3 years while we've operated in other portions of their or in other watersheds or other portions of their watershed. So depending on these conditions that I've outlined here, a wildfire may necessitate short-term or long-term adaptations to a program. And again, you want to have a contractor that you can consult with and counsel with as you make those adjustments and make those seeding decisions. Does that address some of your questions and concerns, David, or would you like me to go into greater detail in any of these attributes?
That's good for now. Thank you.
Okay. Let's go ahead and advance another slide. Just for reference, this was the fire that took place this year, the Apple Fire. Using this as an example, this would be a time where we would look at modifying seeding activity primarily in the northeast target. Based off of discussion, we may cease operations in this more southerly, easterly portion while continuing operations in some of these more northern westerly portions of that target area. We may cease for on a temporary basis seeding in the southwest target if we're afraid that the downwind impacts of seeding in this area would be too great for the sustainability of the apple fire. So those are some of the modifications that we would look at making based off of that fire. Now, fortunately, that fire was contained relatively quickly, and this is one that would probably have had minimal impact on the overall program itself. But again, a good example of the types of things that we would want to take into consideration.
Well, I don't know if I'd agree with relatively quickly because I sat on that fire. So,
okay, that's a good point.
A lot of 12-hour shifts out there. and it was not the only fire in the area. So I can tell you there was overlap in that area as well with the El Dorado fire that came up. And then to the south of the Cabazon and the 10 freeway, they had the Snow fire and then the Sandalwood fire that burnt down the mobile home park over by the Calamasa area. And then, of course, we had the big fire in Elsinore up on the hills not too long ago. So, I mean, it's a fire-prone area. So that is a large consideration and a lot of devastation with tens of thousands of acres that have been burnt just in the last year. I mean, this has been one of the most devastating fire years that California has seen.
Yeah, absolutely. And I didn't mean to minimize the apple fire. In comparison to what we've been watching in Fresno and in that area, this was smaller and more rapidly contained than some of the larger fires that have taken place more northerly. But I didn't mean to minimize it in its own right. That's absolutely true. And as you mentioned, there were additional fires, and that's why it's really important to pick a contractor that is familiar operating in and around wildfires, because the propensity for wildfires is unfortunately very high, particularly in your watershed and in other areas around LA. Fortunately, your watershed consists of numerous potential targets that are geographically isolated, at least to some degree. So that gives us the ability to target certain areas for seeding activity, even if other areas that seeding would not be considered prudent or sustainable. So there is definitely a benefit in your watershed of having some of that diversity and that geographic separation. And that's what's benefited our client in Santa Barbara as well. Southern portions of their watershed were marred horribly by fires that took place a couple of years ago. But we've been able to continue to operate in northern areas of the county. So, but definitely things that you want to be conscientious of. And had we been operating this year, we would have done a deeper dive into the soil conditions after this fire. We also would have worked with flood districts to look at debris flow concerns and other things to determine levels of suspension in that area. Any other questions relating to wildfires or concerns with wildfires and suspension criteria? Okay, for purposes of time, we'll go ahead and we'll move forward. Go ahead and advance 2 slides again. Oh, yep, there you go, perfect. So real quickly, NOC looked at 2 different aspects of operating in the Santa Ana River watershed. We looked at technical feasibility, and then we also looked at economic feasibility. Technical feasibility is based off of a number of considerations, and I think you can click and there should be some bullets that pop up. Yeah, I think there's probably, yeah, that should be good. Oh, one more. There we go. Okay. So for technical considerations, we looked at historic studies. We looked at historic studies on the California coast and in similar climates. We did a detailed climatology review of your particular climate and of climate trends and tendencies. We looked at the geography and topographical attributes of your watershed as well. Then we looked at equipment requirements, what equipment would be necessitated, how that equipment would operate, where that equipment could be located to make sure that, technically speaking, this program was feasible. The only technical limitation that we really ran into in your watershed, because your watershed is really designed ideally for cloud seeding, the one big technical limitation was, again, the amount of air traffic coming in and out of your watershed and areas surrounding your watershed. That did provide significant limitations in terms of where we would recommend operating an aerial component in this watershed. One thing really quickly on aerial, the reason that aerial components are so difficult, it's not hard to fly in and out of LA. We can get approval to fly in and out of LA relatively easily. Seeding activity is very different. A seeding plane will take off and it will operate back and forth on a designated flight path for a period of time, often a number of hours. And so we're not just taking off and leaving the highly dense, highly populated airspace. We're taking off and we're occupying airspace in a high activity area for a long period of time, operating numerous flight paths. And that's why it becomes challenging. We're also operating during storm conditions. So we're operating when visibility is low, when a lot of reroutes are taking place, and when air traffic controllers are at their busiest. And so that's why it can be difficult to get approval in the moment of a storm, even if we have long-term approval and we have all of the correct passes and everything to operate. That moment in the storm, air traffic control can pull us from the air or refuse to take off at any time. So that, just wanted to address those technical challenges quickly. But other than that, we found the program to be technically feasible. Go ahead and advance. Let's advance 3 slides. I'll address economic feasibility here in a minute. You can continue to advance. Okay, and as we address economic feasibility, I'm going to show a proposed budget, some considerations. NOx cloud seeding program contracts consist of 2 forms of billing. There are fixed operational expenses that are typically billed monthly, and then there are variable expenses, which relate to chemicals or products that are used to perform the actual seeding activity, where a fixed amount cannot be determined a priori. So we're looking at usage throughout the season. Another thing to consider is the design and the expenses that we're going to present here are preliminary. The actual program design and actual expenses will be determined throughout the RFP process. We also didn't include first-year setup expenses. So often in a multi-year agreement to perform cloud seeding, the first year will have additional expenses that relate to the setup and acquisition of original equipment. Go ahead and progress to the next slide. And with that, we'll go over the estimate. So here's the estimate for ground and aerial seeding. We estimate that an effective program in your watershed to operate both from the ground and air would cost roughly $400,000 per year or per season. The benefit to cost ratio would be 7-to-1, meaning that we're producing water at roughly $35 an acre foot. Typical cost for untreated, unpressurized, irrigated water in your watershed ranges from $250 to probably $400 an acre foot. We selected the lower number of $250 an acre foot. So we're producing water at roughly 1/7 of the cost of obtaining that water elsewhere. Go ahead and go one more slide, and then I'll pause for questions. Oh, go ahead.
Well, Garrett, the American Society of Civil Engineers manual on cloud seeding talks about the benefit to cost as being suitable, or however they defined it. Could you elaborate on that? And
Yep. So the American Society for Civil Engineers recommends that a minimum 5-to-1 benefit to cost ratio be achieved or be projected for a cloud seeding program. So the cloud seeding program should operate at no more than 1/5 of the value of the water that it's generating. And in this case, we project to operate at 1/7 of that value. Part of the reason for providing that cushion is that there are wet years and dry years. In drier years, the program is going to cost more and benefit less because there's less opportunity to seed. So you want to make sure that even in those dry years, you're getting a positive benefit on the program itself. So targeting a minimum of a 5-to-1 benefit to cost ratio. NOC tries to establish programs with a 10-to-1 benefit to cost ratio. That's our target, to double the efficiency of the ASCE's recommendations. And here we fell right between the ASCE's minimum guidance and our typical recommended benefit to cost ratio at roughly 7-to-1.
All right. And I thought I'd point out that your value of water is fairly low for us in Orange County. We're like 3 to 4 times more than that. So the benefit cost ratio would be 3 to 4 times higher than that.
Correct. Depending on the location within the Santa Ana River watershed, your benefit to cost could be substantially higher.
Okay,
we went with the lowest provided number for raw, and by raw I mean unpressurized, untreated water. Okay, let's go ahead and go to the next slide where we'll show the ground-only seeding projections.
There.
Oops, back one. Okay, here we go. So for ground seating only, we project an increase, or we project a cost of around $200,000 to operate an effective program. We'll be generating water at about $25 an acre foot under that stipulation, giving us or rendering a benefit to cost ratio of the ideal 10-to-1. And again, in certain parts of the watershed, this would be substantially higher, but a minimum benefit to cost ratio of roughly 10-to-1 on average. Any questions on these projections before we move on to next steps and recommendations? Okay, we'll move on. Go ahead and advance 2 slides again. So as we look at the recommendations that we would yield to the commission, with water valued at $255 an acre foot, NOC recommends a total program cap of $450,000. So as you produce and send out the RFP, we recommend that you have a stipulation that programs will operate at or below this threshold on a year-to-year basis. If a contractor presents a program proposal that does not encompass all 4 target areas, remember to decrease the perceived value or the overall cost that should be associated with that program. So a participant in the RFP may recommend that the program be simplified, and from 4, you look at maybe 2 or 3 target areas, make accommodations as appropriate. In terms of qualifications that should be considered in the RFP, we address those in greater detail in the report itself, so I would encourage you to look there. Just some things to be mindful of. The Santa Ana River watershed, there's a lot of politics that go into water that comes in and out of that watershed. There obviously are a lot of member agencies. There are a lot of different municipalities that pull on that water, and operating an effective cloud seeding program in that watershed could take a lot of cooperation between member agencies and member boards. So be mindful of that, aware of that, and if it is sought, or if a weather modification program is sought, make sure that those conversations begin early, that there's understanding and mutual agreement between different member agencies on the promotion and advancement of that program. Go ahead and continue to the next slide. Next steps from a technical standpoint, selection of specific ground seeding locations would be a good next step, and that will be a portion of CEQA compliance. For CEQA compliance, a mitigated negative declaration will be required prior to operating a cloud seeding program or a weather modification program. That process is rather lengthy. It typically takes about 6 to 12 months. We recommend starting that process early if the commission, again, desires to seek a weather modification program. If the commission would like NOC to assist in the development of the mitigated negative deck and in some of the CEQA compliance, we've presented pricing that would be associated with our efforts to help develop those resources. And I believe Mark Norton will go through those in more detail in the following slides. That wraps up the presentation from NOC's perspective. If there are any lingering questions, I'm happy to answer those now if we have time. Otherwise, the 104-page report is very detailed, and there's a lot of information in that report that would help the commission in their decisioning.
Any questions?
Well, Garrett, I'd like to thank you for all your efforts in studying our watershed and providing your ideas on this. Thank you very much.
Absolutely, Kelly. And I'd like to thank you. You've been particularly involved in this process and provided a lot of good feedback and insight throughout the process, and I really appreciate that feedback. There's information that people on the ground will know and understand better than a contractor, and you've been really good at helping us provide and encompass that information. So thank you for that.
I had one question, Garrett. Based on your experience then, you would suspect that a mitigated negative deck would be sufficient and that all impacts could be mitigated in essence?
Yes, based off our experience in California, I don't think we've ever had to go any further than a mitigated negative deck to meet CEQA compliance. And we've assisted a number of clients in developing those in the past. We've worked with LA, we've worked with Santa Barbara, with San Luis Obispo County. So we've worked with a number of clients in California to develop those. Programs are really non-invasive. We do address environmental concerns in the Q&A portion of the report. So if you'd like to see a detailed description of some of the materials that we use in seeding and potential environmental impacts, those are addressed in the appendix and under Q&A. And we also have a portion on climate change. So I'd encourage you to look those over, but it's very minimally invasive. We're using very natural materials, and the materials really have no long-term or lingering effect in watersheds.